Hello everyone, we're looking at more angle pairs today. In the previous section of notes we were looking at pairs of angles like adjacent angles, complementary angles, supplementary angles, and now we're going a step farther and talking about linear pairs and vertical angles. So once again we'll draw some diagrams here as we take a look at each definition. So here we're looking at a linear pair, really two ideas based on the linear pair, and I've already written it down. And this is the definition of a linear pair. If two adjacent angles have their non-common sides as opposite rays, then they are a linear pair. Now, this is a definition, so again we could switch the hypothesis with the conclusion and it would still be a true statement. We saw this a little bit, this linear pair idea, with yesterday's notes. So I'm going back to yesterday's, or the previous day's notes. And when we were taking a look at supplementary angles, and we drew them as supplementary adjacent angles, that's a linear pair. So notice this definition is saying if there are two angles whose non-common sides, so this is the common side, we're not talking about that one, these are the non-common sides. So if the non-common sides point in opposite directions, and they do, then we have a linear pair. So in other words, you have a straight line there because that's 180 degrees. Now because that's 180 degrees, then it's also a supplementary pair, and that brings out the second idea, which is what we call the linear pair postulate. So if two angles are a linear pair, then they are supplementary. So that's the official name, the linear pair postulate. This is the if-then statement that we could use when writing our proof. Again, here's the official name of the definition. Here's the if-then statement we could write if we're writing that in our proof. So as a diagram, let's draw a pair of opposite rays. Again, it looks like a line, but there's your two rays pointing in opposite directions. There's the common side. And so I'm going to number these angles 1 and 2. And so there's a lot of things we can say about this diagram. It's a pretty simple diagram, but we can say angle 1 and angle 2 form a linear pair. We could also say that these same angles, angles 1 and angle 2, form a straight angle. Now you might say it's a straight line. Yes, it is a straight line, but it's also bigger than an obtuse angle, and we classify that angle as a straight angle. We could also say angle 1 and angle 2 are supplementary. So there's lots of ideas we know about such a simple diagram with two adjacent angles like that. That's our linear pair. Now we're talking about vertical angles. Vertical angles are two angles that are opposite one another at the intersection of two lines. So draw two lines intersecting each other, and I'm going to number these angles off. Just kind of work my way around. So angle 1, angle 2, angle 3, and angle 4. So we're talking about two angles that are opposite one another. So we're talking about sort of opposite that point of intersection. You see the two lines form this X. So we're talking about these two angles being a vertical pair and these two angles being a vertical pair. So we would say angle 1 and angle 3 are a vertical pair. We would also say angle 2 and angle 4 are a vertical pair. Now what's interesting about these vertical pairs is that if two angles are vertical angles, then they are congruent. And the official title of that idea is the vertical angles congruence theorem. It's a theorem, which means we would have to prove it to know it's true, but I'm telling you up front, yes, it is true. And so what that means is that angle 1 is congruent with angle 3, and angle 2, I'll give it a double arc, is congruent with angle 4, I'll give that a double arc as well. So we could say angle 1 is congruent with angle 3, and angle 2 is congruent with angle 4. Now notice we're using this word vertical in a different way. Usually when we're talking about vertical in math, we mean up and down. We say things like a vertical line that goes up and down, in contrast with a horizontal line which goes side to side. This has nothing to do with up and down. This is just opposite placement. So no matter how we rotate our diagram, we could say these are still vertical angles. They have nothing to do with up and down, but they are still vertical angles because they are opposite each other across the point of intersection of two lines. So that's what we mean by vertical angles. So let's practice identifying whether these angle pairs are vertical angles, a linear pair, or neither. So notice we don't call this a vertical pair, we just call them vertical angles. And we don't call this linear angles, we call this linear pair. So slightly different phrasing on how we name each of those. Let's look at angles 1 and angle 2. Angle 1 and angle 2, notice that they are adjacent to each other. And if you kind of put your pencil down right there, you can see that they do form a straight line. So angles 1 and 2 have their sides pointing in opposite directions. It forms a straight line, in other words. And so we do have a linear pair. Alright, next angles 1 and 3. So here's 1 and here's 3. Notice that there are two lines crossing each other like a big X. 1 is on the top part, 3 is on the bottom part. That's a pair of vertical angles. Part C, angles 1 and 4. So here's 1, here's 4, and notice that 1 and 4 are next to each other, and they form a straight line, so that's another linear pair. Lastly, in this column, angle 4 and 5. Here's 4, and here's 5. So notice that they do not exist next to each other. They're sort of far apart here. 4 and 2 would be vertical angles. 4 and 5 are not vertical angles. 4 and 5, they have a common side, but it doesn't point in opposite directions. It doesn't form a straight line the way 1 and 4 do. 1 and 4 is a linear pair, but 4 and 5 is not a linear pair. So this is neither. Alright, let's try some more. Part E, here's angles 4 and 2. We talked about that already. That's a vertical pair because they are opposite each other. So I should say not vertical pair, but vertical angles. That's how we name them. Letter F, this is angle 5 and angle 8. Here's angle 5 and here's angle 8. Notice that angle 5 and 8, they are on one straight line, but they're not next to each other. By definition, if we're talking about a vertical pair, they have to be two angles that are next to each other, adjacent to each other, while angles 5 and 8 are not adjacent to each other. So that's neither. Letter G is talking about angle 5 and 7. So here's angle 5, here's angle 7, same story. They are not adjacent to each other, so that's a case of neither. And lastly, angle 5 and 6. Here's angle 5 and 6. Notice that they are adjacent to each other and they form a straight line. That's our linear pair. Now the reason why it's necessary to get good at identifying what kind of angles we are working with, because that will then determine what kind of equations we're going to set up. Remember, we said that vertical angles, looking right up here, we said vertical angles are congruent. That means they're equal in size. So if we were solving an equation, we would set these angles equal to each other. But if we had a linear pair, remember we said a linear pair is supplementary. So if we're working with these two angles, well, we don't set those equal to each other because that's not a vertical pair. No, it's a linear pair, which means they are supplementary, which means we set them up to 180 degrees. And we'll be doing more of that on the next page in a moment. Let's take a look at a few calculations here for example 2. Using this diagram of two lines that are crossing, you see we have angles 1, 2, 3, 4. We're starting off by knowing one angle, and our job is to find the other three angle measures. So angle 4 is 63 degrees. So I marked that in the diagram. Now, if you just jump to the diagram and take a look at angle 4, you can see it is opposite angle 2. We learned that vertical angles are congruent. So if angle 4 is 63 degrees, then angle 2 is also 63 degrees. We know that already. Now when we're taking a look at angles 1 and 3, those are vertical angles, and they will be congruent to themselves as well. So we need to calculate those. And to do that, we're going to use either angle 2 or 4, it doesn't really matter, and notice that we have a linear pair. So we have several ways we could set this up. We could add these two angles up to 180 degrees, or we could add these two angles up to 180 degrees, or we could add those two angles up to 180 degrees, and here's one more possibility. We could add those two angles up to 180 degrees, because there are really 4 sets of linear pairs. So let's focus on these two. We know that's a linear pair, and that'll total 180 degrees. So we'll go 180 minus 63, and that will give us the difference right there. So we're thinking in our head, or using our calculator here, to find the measure of angle 3, we'll take 180 degrees, and then we will subtract away 63, and that result then gives me 117 degrees. So if angle 3 is 117 degrees, then its vertical angle over here is also 117 degrees. And so that's how we can solve these, by noticing the pairs of vertical angles being the same and linear pairs adding up to 180. Right. So one way you can do this, one way you can write down the answer, not just in the diagram, but one way you can write down the answer in your homework, is you can do something like this. You can say the measure of angle 1 equals the measure of angle 3, because they are equal to each other, and we know that they are both equal to 117 degrees. So you can write it that way if you like. Say the measure of angle 2 equals the measure of angle 4, and they all equal 63 degrees. So that's how you can set it up. I'll skip part B. We'll go to some more involved problems on the next page. So if you'll flip to the next page, let's take a look at example 3. Alright, the challenge here is to recognize what angle pair we have. So I'm going to write that down, even though the problem doesn't say to name the angle pair. That's the first step we need in order to write an equation and solve the equation, and we're going to solve for x. So we go to the diagram and we look at the angles where we have information, meaning numbers or expressions. So this angle has no number. We're not going to use that. This angle, again, has no number. But here's a 113. We're going to use this angle. And here's a 4x minus 1. We're going to use this angle. So now we ask ourselves, now that I've found the two angles that have information, what kind of angle pair are they? Are they vertical angles, or are they a linear pair? So you can form a straight line, and these two angles are adjacent to each other. That's a linear pair. So I'm just making a note that we are working with a linear pair, and the reason for that is because we learned that a linear pair is supplementary. Right, and we learned that supplementary means they add up to 180 degrees. So that's how we build our equation. So we take this angle, which is the 4x minus 1, and we add to that the 113, and set them equal to 180 degrees. So that's what the supplementary is telling us to do. Let's combine like terms. On the left-hand side, we have a negative 1 plus a 113. That combines to a positive 112. Now I'll move my constant terms to the other side. We'll subtract 112 from both sides. And so we have 4x equals 68. And lastly, divide away the 4. The problem asks us to solve for x, and we did. We don't have to plug it back in. And there it is, x is 17. So contrast that diagram with the next one. Again, we have two lines crossing. find the angles with information, so not up here, not down there. But we have an angle on the left with a 4x minus 18, and we have an angle on the right with a 3x plus 4. So now that we've found where the angles are, we then have to identify what are they. These are vertical angles. And we learned that vertical angles are congruent. So if they are congruent, that means they are equal in size. So we will set these two angles equal to each other. The angle on the left, 4x minus 18, is equal in size to the angle on the right, the 3x plus 4. That's how we know how to set up the equation. So notice we're not adding this up to 180 because it's not a supplementary pair. I'm going to start by moving all of my terms with x to the same side. I'm going to subtract 3x from both sides. And so we have x on the left minus 18 equals 4. Let's move the constant terms to the right. So I'm adding 18 to both sides of the equation. And so we get x equals 22. And we solve for x, so we're good. Again, it's not asking us to plug it back in, so we don't have to do that. Example 4, more of the same, but we're taking it up an extra level as we now have more angles with information. Above, we just had 2 angles with information, but now we have 1, 2, 3 angles that are labeled. The fourth is not in this case. So now we have to think about how we're going to figure out where to start. I can pick 2 angles. For example, I could pick these 2 and say, yeah, that's a linear pair. They would add up to 180 degrees. Again, there's your straight line. Right, so that's how we know it's a linear pair. They would add up to 180 degrees. And that's true, but this is an x and this is a y, which means we can't really do anything with that because there's too many variables. Alright? Well, here's some vertical angles. We know vertical angles are congruent. We can set those equal to each other, right? Yes, but we can't solve it because they are 2 different variables and we just won't be able to make any progress. So when you are picking your angles to start, you want to pick 2 angles that have the same variable. That's where you need to start. So I'm going to write that note down here. Start with the 2 angles that have the same variable. So I have an angle with a y, I have an angle with an x, I have an angle with an x. We want the 2 angles with an x. So we identify what kind of angle pair they are. We form a straight line. These 2 angles are next to each other. That's a linear pair. Alright, so we'll take the angle called 16x and we'll add it to the angle called 9x plus 5 and set those equal to 180. Again, we did that because they are adjacent to each other and form a linear pair. A linear pair is always supplementary. So now let's solve for x. 16x plus 9x is 25x. And then let's move our constant terms to the other side. So I'm subtracting 5 from both sides, so I get 175 on the right. Let's divide away the 25 to isolate the variable, and we get x equals 7. Alright, so now we know that x is 7, and I still have to solve for y. And I don't have another angle to pair up with the angle that has the 4y. So what we're going to do, we're going to take that 7 and plug it back in so that we could figure out then a pair of angles to then work with to solve for y. So if I really like these vertical angles, let's say that I really want to use that angle on the left and the angle on the right, then let's take that 7 and plug it back into the 9x plus 5. So let's think about this. The 9x plus 5 means that we have 9 times 7 plus 5, and that will give us 68 degrees. Okay, so now we know this angle is 68 degrees. So our next step here is now we're going to use the vertical angles to solve for y. Meaning the angle on the left here and the angle on the right. So we know vertical angles are congruent, so that means the angle of 4y is equal in size to the angle on the right, which we now know is 68 degrees. So we divide away the 4, and we get a result of 17. So part of the trick here is reading the information and picking a good place to start. So let's try that again with part B. Uh-oh, now we have all 4 angles with information. Okay, sort through it by finding 2 angles that have the same variable. This angle on the top left corner is an x. This angle on the top right corner is a y, so we don't want to use those 2. This angle on the bottom right corner is an x. We found a pair. Those 2 are x's, and they happen to be a vertical pair. So let's start by solving for x. And if I want to solve for x, I'm going to take these 2 angles and identify what kind they are. They're a vertical pair. We know vertical angles are always equal to each other. So we're going to set these expressions equal to each other. So we have a 9x plus 2, and that will be set equal to the 10x minus 7. Alright, so now I'm going to move all of my terms with x to the right hand side. So we get 2 equals 1x minus 7, add 7 to both sides, and you can see we have a value of 9 for x. Alright, now we have a couple of choices here. The easier choice is to work with the 2 angles that have y's. Again, it's a vertical pair, just set them equal to each other. But technically, now that we know x, we could plug it back in and then work with these 2 angles, and that would be a linear pair, and add them up to 180 degrees. But it is easier to go with the vertical pair with the y's. So let's do that now. Let's solve for y. Again, they're vertical angles. Vertical angles are equal in size. So we have this angle of 18y plus 25 equal in size with the 9y plus 61. Alright, let's move all the terms with y to the same side. I'm subtracting 9y to both sides. So we have 9y plus 25 equals 61. And then let's move all the constant terms to the other side, subtracting 25 from both sides. So 9y equals 36, and then divide away the 9 to get y by itself, and we get 4. So x is 9, and y is 4. There we go. So those are the big ideas, talking about linear pairs and vertical angles, how to read the diagram, set up an equation, and solve for the variable. So what we're finishing off with today is really not so much about the angle pairs that we've just been looking at, but it's a little mini practice proof, and it's introducing a new concept that we're calling the right angles congruence theorem. So think about this. If you have 2 angles that are right angles, then they are congruent. That makes sense, right? If you have 2 angles and they're both right angles, they both have to be equal to 90 degrees. So we're going to prove that because it's not a postulate, it's a theorem. Now it might be a small theorem, and it takes a small proof to talk our way through it, but let's use this diagram as an example. Here's angle K, here's angle L. I have 2 angles that are right angles. What we have to do now is prove that they are in fact congruent to each other. So first, take a look at the given information and jot that down in statement number 1. So angle K is a right angle, and on the same line, angle L is a right angle. And that's given to us. Okay, well, what do we know about right angles? We know that the definition of a right angle is that if it's a right angle, it's equal to 90 degrees. So that's where we're transitioning. If an angle is a right angle, then it equals 90 degrees. So again, think of line 1 as your if, and line 2 as your then part of the if-then statement we're going to write for reason number 2. The if always describes what came before. If an angle is a right angle, then its measure is 90 degrees. then its measure is 90 degrees. So what we just described is in fact the definition of a right angle. So you could either write down the official name of this idea, or you could write down the if-then statement. We did both just so we could kind of see both in this case. Now you can see they're leading us to use the transitive property here. And so what we want to do is we want to take a look at these equations and recognize that we have three ingredients. Angle K is the first ingredient. Here's 90 degrees, we can call that the second ingredient, and look here it shows up again, that's the same ingredient, and angle L is the third ingredient. We have three components, and remember, if we have two pairs of them, we can create a third pair showing that the first and the last are also congruent to each other. So if the first is equal to the second, and the second is equal to the third, what do we know about how the first and third compare to each other? Right? If both angles are equal to 90 degrees, then that means both angles must be equal to each other. So it's the transitive property of equality, because we have an equal sign, not the property of congruency, that would be the congruent sign, linking all three of those together. Now remember, we wanted to show that these angles are congruent. We didn't say then they are equal, it says then they are congruent. We have to show that these two angles are congruent. So we have to then transition from this equal sign to this congruent sign. So again, think of an if, then to write. So if two angles are equal in measure, comma, then they are congruent. And we saw that in our previous examples. That is the definition of congruency. So if you like, you can just use the official title. That happens to come up a lot, and so you might prefer to use that title instead of the if-then. And that's it for our notes today.